So today let's have a look at the ODE equations and how to solve the ODE equations, how to find the general solution of the ODE ordinary differential equations. Now the ODE equations are in that form. It's a second order. The reason it's a second order is because here it's a d square y, second differential. If that was a third differential, that's a third order. And this is how the second order differential equations look like. To solve the second order differential equations, what we do is we just write it down, y equals to e to the power alpha t. The alpha, because we have to use a constant, and the t, because everything is differentiated with respect to t. After you got this thing, you need to differentiate it because you got the y. This y is e to the alpha t, but I don't know what is dy over dt. So you're going to differentiate it. Now differentiate this thing. With respect to t. So that thing will become a dy over dt. And you know the differentiation of e to the alpha t is exactly same, e to the alpha t. And we have to differentiate this thing so that alpha will come out as well. So that will be dy over dt. This is one of the bits. So now I got this dy over dt as well. But I don't have d square y over dt square. So I will differentiate that thing again. That's d. When I differentiate that respect to t, that will be dy, so d square y over dt square, second differential, equals to e to the alpha t. Differential of e to the alpha t is e to the alpha t. There is an alpha already there, and there is another alpha that will come up. So that will become the alpha square. Now I got that bit as well. Which means I have this bit. Now once I got that bit, I will put this thing into the equation. So d square y over dt, this is the value. So I'm just going to write this thing down as, instead of that one, I will write down alpha square e to the alpha t plus a 5. The 5 is as it is. Dy over dt is this one, alpha e to the alpha t. E to the alpha t plus 6 is as it is. But then there is a y. This is the equation for the y. Y is e alpha t. And that's equal 0. Now this whole thing is equal 0. If you have a look here in the equation, there are few things that's common. For example, there is a e to the alpha t here. There is a e to the alpha t here, and there is a e to the alpha t here. So I can take this thing as common. So e to the alpha t common, and what's left? Alpha square is left, plus what's left? 5 alpha is left, plus 6 is left, equal 0. Now this is called the factorization. Now then there are, this whole thing can only be 0 if this number is 0 or the one inside the bracket is 0. But e to the alpha t can never be equal to 0. Why it can't be equal to 0? E has a value 2.7 something. And alpha, you can choose any value of alpha. You can choose any value of t. You put that in calculator, you will never get an answer 0. So that is never going to be equal to 0. So what's left then? So for the whole thing to be 0, this thing has to be a 0. So this thing has to be a 0 now. So I'm just going to put that thing as a 0. So in that case, alpha square plus a 5 alpha plus a 6 equals to 0. Now, if you have a look, this looks like a quadratic equation. Now, we are going to solve the quadratic equation. Okay, now we got this quadratic equation from here. This looks like a quadratic equation. So we need to find a value for the alpha for which this whole thing is 0. So the way we do is we will go for, okay, quadratic equation. You can do factorization or you can do quadratic equation. Let's do quadratic equation. So quadratic equation is this: alpha equals to minus b plus minus b square minus a 4ac over 2a. Now in this one, the a is what's attached to here. This is a, this is a b, and this is a c. So a is 1, b is 5, and c is 6. So then you put the values there. Minus b, so it's going to be minus 5 plus minus 5 square minus 4 times 1 times 6 over 2 times a. When I solve this thing, I will get minus 5 plus minus 25, 5 square is 25, minus 24 over 2. Now that will give me minus 5 plus minus square root 1 over 2. Square root 1 is just a 1. Minus 5 plus minus 1 over 2. Now I have to use, this is the value for the alpha. Now I can get two values for the alpha. So let's change the color. Let's use green. So it means the alpha is equal to minus 5 minus 1 over 2. And alpha is also equal to minus 5 plus 1 over 2. Which will give me alpha equals minus 6 over 2, which is minus 3. Alpha equals minus 4 over 2, which is minus 2. These are the two values that I get for the alpha. Once I got these two values for the alpha, I need to put into an equation. Now I got two values for the alpha. The two values of the alpha is alpha equals minus 3, alpha equals minus 2. So if you remember, this was the first equation we used, y equals to e alpha t. I will put the value here in this equation. So I will write down, so y1 equals to e alpha t, so minus 3t. And then y2 equals to e alpha t minus 2t. Yeah, where I got the minus 2 and minus 3 from these two values of the alpha. I have two roots now. So once I got two roots, once we got these two roots, we write the general equation for the ODE, the general solution. And GS, we call it GS, general solution for the ODE, which is given by y equals to a. The general solution of the ODE is represented by y equals to a, y1 plus by2. Now you have the value for the y1, you have the value from the y2. y1 is that one and y2 is that one. So you just put these values here and this will be an answer for the general equation of the ODE.